Trigonometric double angles, part 1. Double angles, in other words, twice theta, twice x, twice a, twice b, cos, sine. Luckily we're not dealing with tan at the moment, that's a more complex formula. Cos of 2 theta, well, let's split it up into theta plus theta. Hopefully, if you're not sure, go and ask a grade 8. Now that can be put into our cos sum compound angle formula. Cos of a plus b, cos a cos b, minus sin a sin b. So cos theta, minus sin theta. And cos times cos of theta, cos squared, and sin squared. There is our first double angle formula. Please note, this is a minus, very different from when it's a plus. Obviously, when it's a positive there, then we just have one. It's the Pythagorean identity. But this is now the double angle formula with a negative, and there is our first one. Note that if you see sine squared minus cos squared, well, that's just the opposite in sine. So sine squared minus cos squared would be negative cos 2 theta. Now, sine squared plus cos squared, we've just been talking about, we know, is equal to 1. That gives us two other Pythagorean identities. Sine squared equals 1 minus cos squared. Cos squared equals 1 minus sine squared. Now what we're going to do is take each of these in turn and substitute it into the original formula, and it's going to give us two more formulae. There are 3 cos double angle formulae, and they are appropriate for different situations. So the first one, I'm going to take sine squared, and I'm going to write 1 minus cos squared instead. So there we are. There's our double angle formula. Now I'm going to take that 1 minus cos squared, and I'm going to slot it instead of the sine squared. Now if you simplify that, minus 1 plus cos squared, we're going to end up with 2 cos squared minus 1. So there is our second double angle formula for cos. Now we can get on with sine as well, because I'm going to go back to my original one, and I'm going to get rid of the cos squared by writing 1 minus sine squared. So let's take the original one, there it is there. Now cos squared, I'm going to write 1 minus sine squared instead, and if you simplify that, 1 minus 2 sine squared. So we now have 3 double angle formulae, all for cos. Let's find the sine double angle formula. Sine of 2 theta. Now do you remember what we did with cos 2 theta? We wrote it as cos of theta plus theta. So we're going to do the same with sine. Now sine of a plus b has an expansion. Sine a cos b plus cos a sine b. Therefore, I'm going to write sine theta cos theta plus cos theta sine theta. And while these are written the other way around, they are in fact like terms, because cos sine is the same as sine cos. The direction of the multiplication doesn't matter. So if I've got one here and another one there, we have 2 of them. So there is our formula. Sine 2 theta is 2 sine theta cos theta. 4 formulae now. Better to remember them. Once again, I'll say you will receive a formula sheet with them on in most exams, so we can actually rely on that. But unfortunately, you cannot rely on that formula sheet reminding you and helping you to recognize various mathematical statements. When I see cos squared minus sine squared, I recognize and say that reminds me of something, and at least let it remind you of something, one of the double angles, and then you can come back to the formulae if you want to. Notice cos squared minus sine squared, not cos squared plus sine squared, which would give you 1. So this is the double angle formula. Cos squared 75 minus sine squared 75 gives you cos twice 75. Cos 150, second quadrant 180 minus 30. Cos is negative, so we reduce it to negative cos 30, because 180 minus 30 and 30 have the same x, y, and r. other than their x's being opposite in sign. That negative there has allowed for that. And that gives us negative root 3 over 2. Special angle 30 goes to root 3 over 2 for cos. Another one. Cos squared 75 plus sine squared 75. Now after all that I've been talking about, surely you're going to go straight to the answer there. That's your Pythagorean identity, 1. As long as the angles are the same. Don't be caught out and be given something like cos squared 75 plus sine squared 15 degrees, because then that won't be a Pythagorean identity. 2 sine 75 degrees cos 75 degrees. Well, look at the pattern. 2 sine cos. I've seen that before. Here we are. 2 sine cos gives us our sine 2 theta. So therefore this is going to be sine of twice 75, sine of 150, second quadrant, therefore sine of 30, 180 minus 30, and sine is positive, special angle half. 2 cos squared 135 minus 1. Well, pattern again. 2 cos squared theta minus 1. Yes, I remember that. Look, there it is. Cos 2 theta. So therefore this is going to be cos twice 135. There we are. Twice 135. And twice 135 is 270. Now you can put that in your calculator. You can memorize it. It's without the use of a calculator, but remember, nobody will know. But the easiest is the graph. I mentioned it in a previous video. Because we can picture this. Cos starting at 1 and then going down and coming back up to 1. Now, 270, 0, 90, 180, 270. Oh, cos 270, 0. 1 minus 2 sine squared, 67, 5. Well, yes, 1 minus 2 sine squared I recognize. The cos double angle formula. Therefore this is going to be cos twice 67, 5 degrees. Cos 135, second quadrant, cos 180 minus 45, reduced to 45, cos negative, negative cos 45, cos 45, well, 45 is a special angle, so we get negative root 2 over 2. Now this is the binomial squared. Remember, if you're not sure, ask a grade 9 student, yes. Square the first term, multiply together, and double, which means it takes the negative with it. Square the last term, which means the negative is changed to a positive. There we are. Square the first, multiply the two together and double, so there's the sine, the doubling, and each of them in the product. Square the last, so that squared becomes a positive, and it's cos squared. Now you'll notice that I've written those in blue. Bit of a hint, bit of a clanger for you. Hopefully you could take the hint. Sine squared plus cos squared. 1. The blue one. Now 2 sine cos. There's 2 sine cos, double angle formula. So therefore 2 sine 22, 5 degrees cos 22, 5 degrees will be sine of twice 22, 5 degrees. Well, quite simply that's sine of 45 degrees. 45 degrees is a special angle, sine of 45, root 2 over 2. So there we are. Go on, find a common denominator. It's better that way. It's neater. So there we are. Exercises. This is the stage at which you should pause this video and do these exercises. Remember, you only learn maths by doing. You do not learn maths by watching. answers ahead. Let's go to the answers now. The first one, cos squared plus sine squared. Both 45, 1. We could have substituted in and said, well, that's 1 over root 2, root 2 over 2 all squared plus root 2 over 2 all squared, and it'll give me 1, but you should be able to see it immediately. This one here, cos squared minus sine squared, same angle. There's our cos squared minus sine squared, cos of 2 theta, cos of twice 45. Think of the cos graph down, it's on 0 at 90 degrees, 0. 2 sine cos of the same angle, there we are, 2 sine cos, sine 2 theta, therefore this one's going to be sine of twice 15, sine of 30, half, special angle 30. Here's your binomial squared again. I put the blue again, square the first, multiply the two together and double, so it takes the positive with it. There's the doubling, and there the 2 in the product. Square the last, there we are, plus, always plus cos squared 15. Sine squared plus cos squared, 1. 2 sine cos of the same angle, there we are, sine 2 theta, therefore this is going to be sine of twice 15 degrees, sine of 30, which is a half, plus 1 gives you our 1.5. 2 cos squared minus 1, well, there's 2 cos squared minus 1, cos 2 theta, so cos of twice 15, cos of 30, root 3 over 2. 1 minus 2 sine squared, well, there we are, 1 minus 2 sine squared, cos 2 theta, so therefore I'm going to write this as cos of twice 112, 5, cos of 225, third quadrant 180 plus 45, cos negative in the third quadrant, cos of 45, root 2 over 2. Number 2. Simplify this expression into a single trig ratio of A. Well, quite simply, that's the case of expanding there. Remember, cos A, cos B minus sin A, sin B. Cos A, cos B plus sin A, sin B, the formula. So therefore, I've used my formulae. There is cos of 60 plus A. Cos, sin pattern with the negative. There is cos of 60 minus A, cos, sin with the positive there. Now, coses, there, sines go, so therefore we end up with 2 cos 60 cos A, like terms, 2 of them. Cos of 60 we know, it's a half, special angle, and that gives us cos of A. Calculate the value of cos 105 plus sin 15 without a use of a calculator. Now, we can write cos of 60 plus 45, we can reduce that to cos of 75 and have cos of 45 plus 30. We could write this as sine of 45 minus 30 and those huge expansions and everything. But quite honestly, it's part of question 2. And the first part of question 2, we said find an expression for cos 60 plus A, cos 60 minus A. Well, there's a cos something. So if you have a look at that. Let's look again. There we are. There's your 60 plus A. There's your 60 minus A. So 60 plus what? 60 minus the same thing give you those two values. Rack your brains on that one. A must be 45. There we are. So I'm going to write cos of 60 plus 45, cos of 60 minus 45. to fit that pattern there. Now, that there we've found is equal to cos of A. So the very next line we can go cos of A. And the A is 45. 60 plus A, 60 plus 45, 60 minus A, 60 minus 45. So therefore straight to cos of 45 degrees. Special angle 45 degrees, therefore root 2 over 2.